Okay, our next speaker, Sonny Ward. I've known him for a few years, off and on, really about a little over 10 years. And he's been holed up in Idaho and has raised a family up there and just been generally involved. He told me to introduce him as arrogant, obnoxious, and flamboyant, but a nice guy anyway. And he stressed obnoxious. He got into inventing under the influence of and inspiration of John Bedini, who's a legend in this field. John Bedini spoke at some of the very early Tesla conferences and really had some impressive systems even at that time. And Sonny has taken the ball and run with it and built some incredible technology that actually works. So let's hear from him.
Today for supporting me for the many years and believing in me, and of course some of the people that got angry. I remember one time in Tulare, Paul Fantone and Steve Ellswick and I were there, and I had my car in the parking lot, and one gentleman came up and got very, very angry, and he said, "You know what you're trying to do here?" He said, "Can be done." I said, "How's that?" He said, "Well, it's burning gasoline, the car's running, and the tailpipe's getting colder and colder, not only the muffler too, and it'll suck your finger in the tailpipe." I said, "Well, that's pretty amazing." And that's what this little machine I invented here. So Lockheed has looked at it. I got a letter from the federal government. It's the first implementation. It's called cylinder deactivation in multi-port computer-controlled cars in the world today in 1993 from the Department of Energy, Department of Transportation. It was achieved with this machine that I invented and patented. But they waited until 2000 until the patents run out. Now it's standard equipment on many, many cars. And GM just announced that they was the first ones to actually implement it. They did mess with Cadillacs back in the old years, but they never did perfect it. And I sold thousands of these machines. And one of the amazing things you could do is go back to the car and stick your finger in the tailpipe and it'd suck your finger in the tailpipe or a dollar bill or a napkin. And I used to really get a kick out of it because here would be coming these great engineers. They get down on their hands and knees like a bunch of dogs and sniff the tailpipe and taste the gases come out and everything else. And so they sent John, and he was with Lockheed Martin at that time, and he said, "Well, you know, Sonny," he said, "what you're trying to get people to believe here violates the second law of thermodynamics." I said, "Well, I know that, and you know that, John, but my machines don't know that." And so I continue to defy what can be done. This here just has a cam, 2 micro switches, a little pendulum on here. You mount it in your car. When you deaccelerate, the pendulum swings ahead, opens the micro switches, shuts the fuel off to your car, deactivates it, thereby it uses no fuel. Today they got a different idea for it. They call it a hybrid. My car has 307,000 miles on it. It still runs, it still doesn't use very much fuel, and holds 10 world records. It still averages 55 miles a gallon. It holds one world record of 88.54 miles per gallon at 75 miles an hour. It holds 2 world records over Jackson Hole, Wyoming, 57 miles a gallon, over to the Virginian and back to Rexburg, 78 miles each way. Also, the next year, I upped it to 69 miles, it's been a long time, 69 miles a gallon over and back, and broke every record there was. So the government, you know, they said, "Well, you know, Sonny, you're real good." They call me the kid all the time. "You're a real good kid. You got some real good ideas, but you got it all wrong here. You know, we're the ones that set the policy. You're politically incorrect." And so I wrote to Honda. I took it to Honda. I took to many people, asked them. I said, "Well, what does this mean?" And they said, "Well, we set the policy. Who do you think you are? We have the greatest engineers. You know, we have all this technology, and you're trying to tell us, you know, that you can beat anything. Well, I'll put my car up against any hybrid, any machine made, any hydrogen powered car. At the time it was documented to be the cleanest machine on the face of the earth, and still is. And it'll beat anything there is. It's a 1993 Honda Civic with this machine installed in it. I sold thousands of these over the years in Europe and everywhere else, but as of 2003, and it's a form of implosion technology. You can take two other cars, put them in a parking lot, start this up at 123 degrees, and the tailpipe will get cooler and cooler and cooler. The muffler, if you hold your hand over it, take it off, it'll put out clear drinking water. Steve Ellswick has seen it, Paul Pantone, and I think many other people in this audience. So I was always interested in John C. Bedini. So to take it further, he talked about free energy generation in this little book. And I got quite intrigued about it. And so recently, we made, this is the brand newest edition of this form of the battery charger. Now, somebody would say, well, this is nothing, because it's small, but this thing will put out a tremendous amount of juice. And one that's out in the foyer out there, plus several power tools, plus chop saws, an electric scooter, cell phones. We can charge those things with infinity. And Pons and Fleshman, years ago, right here in Salt Lake City, accomplished what they call cold fusion. I call it implosion because it's more politically correct. And this machine here, of course, it's off, and we'll turn it on. This weighs 2 pounds, okay? And the switch is already on. So if you set the timer, it'll put out 110. Okay, but the wire just fell off. But anyway, the whole idea is when this happens, it is much more efficient. And while I'm on that, I want to show you the very first one, thanks to Bruce Meelan. This is the very first machine that we built over 5 years ago. This machine, I hate device, that's not a good word, or this apparatus, is capable of putting out 1,500 horsepower, and you plug it right in the wall. And we charge 10 Optima batteries simultaneously. This will put out 150 amps, and I'll show you the inside. And we powered those batteries, and then what we learned was that the power coming from the wall wouldn't match this. In other words, it drew more that was capable, so it'd kick the breaker out. So then we upgraded. These here put out around 2 kW, and here it is. This is what it incorporated into it. Maybe I can't get it off. Somebody put it together so good I know it was apart a minute ago. Here we go. And there's the inside of it, right there. Okay. Well, so as we went along, I got more curious. This was like 5 years ago, and I'd done this because I have another machine. It's called the Implosion machine. And what it does is actually you put solid matter or waste into it, excuse me, and it will make it disappear. And I don't know if I think anybody ever heard of Charnkov, but I've got a whole folder on Charnkov here. And, you know, you just have to take my word for some of this because I don't have time to bring 10,000 books and 10,000 references and all that stuff. Even if I could, I wouldn't. You just have to take my word. But it shows you the particular wave pattern of this, and it tells you about Charnkov, tells you about Berkeley, tells you about it being over unity or antiprotons, neutrons, whatever you want to call it. It even shows the fact of the wave, and it's called infinity or figure 8. And there's some more pictures of it. Probably you can't see them very well from out there. Okay, and this gives all the documentation. Here's some more. Okay, and I got this from Alex Peterson. Everybody knows him. And the reason this was important, I didn't know this at the time because I hadn't got that far, But actually, in one of these papers on page 56, it says it's similar to a half-tuned radio antenna. Now keep that in mind as we go along. So I didn't know, and so I took a charger identically like this, and the Department of Energy had already been to my home, and they said, this is incredible. This is the most fantastic thing we have ever seen as far as the energy efficiencies and the transfer of energy. But they said, test it and see how long it'll last. So we did that, and that was almost 2 years ago. I've got some little bitty batteries out there. We built even an electric motorcycle that was featured in Extraordinary Technology for a specific purpose of testing these batteries. I suggest anybody that's interested in this get this, and it tells about some of the tests we did and about, if you want to call it over unity, cold fusion, cold electricity, anything you want to name it. It actually works and what it did. And those batteries are the same ones sitting out there, and they've been charged and discharged all this time. They've yet to ever been heated. When you charge them with this type of energy, they'll go up to as high as 16.7 volts per battery. They never heat, they never boil, they never deteriorate. Now somebody might say, well, why is that? Why don't they heat up? That's impossible. Well, it's also impossible for the tailpipe of the car not to get hot when the gasoline engine runs, but it all uses implosion. So to go on with it further, the guy that I'm really interested in, of course, most people here are, is probably Tesla. And so I have a very, very special book here. And the reason I don't even show this book too much is because people get a hold of it and you see the bindings all busted. And I treat my books, any of them, very reverently. In this book, we still got sound. In this book, shows all this stuff he's got, but it also shows where he builds these capacitors, and this is what he used to power the magnifying transmitter. And what this entails is in fact, the very system I'm going to show you is what Tesla claims that he powered it with. Now, there they are right there. There's the capacitors that he actually used. And he shows the machine he used and what he done, converted from AC to DC, charged the capacitors, and he tells this. And this work, I haven't ever seen one before like it, and I have other books. In fact, I co-sponsored another book that he tells about the cooling effect, and I've lectured on it many, many times on page 56 of his lecture before the New York Academy of Sciences. He tells about the cooling effect. He said it's exaggerated G.G. Thompson. But these are the actual capacitors. What we're using out there, Walmart batteries, you can buy them right off the shelf. Tesla had to make his. And most people, they have a lot to say, but knowledge is kind of like when you go to a drinking fountain. You can either gargle with it or you can drink it. And a few people drink it, and they got some, I like to call it misconstrued conception of reality or what the reality is in their mind. But it actually shows this. This here, in Tesla's later days, he was called in for heavy indebtedness. And this is his testimony of being on the witness stand in court through the federal judge and asked these questions personally. Here's another one. People don't even know anything about magnifying transmitter. Most people think the copper ball at the top, and it was suspended or hooked up or whatever, and Tesla tells specifically in here that it was not made out of copper. It was made out of iron, galvanized iron. He also said there was a certain type of a lumber, that he got a certain lumber yard, and that's what he suspended it on. And unbeknownst to most people, if you look in this work and other works, there's a second tower. And the reason of it is because it would never work as he anticipated. Tesla, in my opinion, and I don't say this, arrogantly or anything else, failed on the magnifying transmitter. It never did work in the first place or in the second place or the last place. And so what he actually did is he put up another tower, And that's also listed in this book here. And this college guy, he was a professor, set assignment apart for his students to research this, and by chance, they found it in the archives. You see, and here's some of these other ones, and here's another interesting picture. This is catching energy from the ether, and it shows he can only power one light bulb, but it's a big coil here, but only can power one light bulb. So in here also, under these capacitors, it tells the highest that he ever took it to was 240 volts, and that's what he used. And he made the capacitors himself, still the work of Tesla. All the start capacitors that are used today still use his technology. And he had to get the air out, and he sealed them with beeswax combination, half and half, and paraffin, still the method used in start capacitors today. And why the capacitors are so important, whether they're batteries or standard capacitors or start capacitors, as he said, they could hold seas of energy. They were more powerful than TNT, and yet they could be discharged in a short period of time. And the work, as far as Tesla did in capacitors, I think is what set the technology for today, but he built them all himself. And then I wanted to go on, I'm trying to cover everything else. This Cherenkov person that I'm telling you about, this came from what used to be the Atomic Energy Commission. It's better today known as the INNEL. My stepfather was one of the very top, if not the top, nuclear physicists at that time, Calvin E. Larson. A picture of him is in here. But if you look on a certain page right here, it tells you about who Cherenkov really was, and he tells you that the acceleration of electrons can be taken beyond the speed of light, and he done it with cobalt 60. And that's how the batteries charge. Maybe that ain't the one, but anyway, it's cold in here. That's how the battery charges. Instead of charging through the plates, they charge directly through the electrolyte, in and out, because the electrons are going very fast. And then I have a compliment or whatever for Hal Fox. This is one of his books. It's called New Energy News. And back before this machine was built, I had what I called an end motor. And there was a person named Toby Groats that tested the end motor, and it was published right here. And it says this thing was over unit, and it put out 67 more watts than it consumed, which it was, and which it did. And I still have that machine, but it has moving parts. And later on, Toby Groats, kind of reneged. And I put out a law here that documents what Yul Brown said and everyone else. And it said it puts out 33% more usable energy than it consumes, which it actually does. So what you're going to see today is I couldn't move all my equipment down here and set it up and move it out. And I tried to explain it to Steve Ellswick, and I think we had a communications misunderstanding, because I don't have a little Tonka truck out there. I got a monster truck. I don't have, a few light bulbs. I got heavy-duty power tools. We can pull up to 10 kW out of this machine. And the beauty of it is it'll charge very fast, very free. Give you some statistics or some data. Ordinary batteries take 8, 10, 12 hours, depending on the discharge. But you'll never get them to charge in 2 hours. Our system will charge in 2 hours, higher, faster, and no heat. And one of the tests, we put them in a room that was 40 degrees. They charged up in 1 hour and 45 minutes. This is 4 Optima batteries to 16.7 volts, no heat. Paul Pantone has witnessed that at his shop. The Department of Energy has witnessed it at his shop. And when they took the charge at NASA, they witnessed, and that's the first I really totally understood it, the figure 8 effect, or better known as the Cherenkov. If you read about Cherenkov in this literature, that Alexander Hamilton, and why I mention these names, maybe some people know these people, said if you could cancel out the frequency, you'd get infinity. So people, I sold a few of these, started to sell them. I thought people would really be interested. I thought they'd want to get off the grid. I thought they'd want backup energy. I thought they'd want free energy. I thought they'd want over unity. But no, you know what they wanted? They'd take my chargers and tear them apart. First thing they'd get them, they'd tear them apart. They'd tear them all down, and they couldn't find anything inside because there is nothing inside. And they was looking for something mysterious, and there was nothing. So then you know what they'd do? They'd start tearing away the little intricate parts. And then they couldn't figure out anything, so then they'd start tearing apart these diodes. And the reason they couldn't get anywhere is because these diodes are very, very special. In fact, recently, we thought we had sunk in the water because we got them from RCA. They sold out. There are no more. So thanks to people believing in me and factory help at a large scale level, we were able to find some replacements. But what we can do with these diodes, you see, we have the ability to a laptop computer to program them so they have what's called PLC, programmable logic control, just like a computer. So what they basically do is they have the ability, so when you pull a big load, they won't let it through, just like the capillaries in your body. And as you lighten up the load, they let more through, so you get a pull-pull effect from both ends, so it has to drain some out of the capacitors. Then when you're not draining it, then it pushes more into it. So how does that affect you? Well, just say, for instance, you plug this into the wall and plug in your refrigerator, freezer, washing machine, or whatever, there'll be absolutely no surge load, and that's usually most of the load. Or we'll say you take it up with you in your RV and you got unlimited power. We've done tests on the batteries, and they'll last for hours and hours and hours and hours with heavy loads, because when you charge them with this cold energy, once you discharge them and recharge them, the batteries become a lot different. We can charge cell phones, we can charge laptop computers, we can charge big Optima batteries. We've got marine batteries out there that are 1,000 ampere hour, 850 cold cranking, and we can charge them just as fast. In other words, instead of taking, you might say, days and a lot of energy, it takes very little energy. This particular charger was set to charge 10 batteries at a time, 125 volts, and take them up to 144 volts. This original we had would take them up to 167 volts, and then it would collapse and go back to 155 with absolutely no boil, no damage, no heat, nothing. And those batteries out there, the little lawnmower batteries, like I say, have been used almost 2 years, charge, discharge on this machine, these other machines, and never, ever had one drop of water added to them. And a couple of my friends fried some of them through their ignorance. We had this other bigger motorcycle we got from Bruce Meeland, and we put them in that because we wanted to stress them more. And unbeknownst to me, we'd shipped it all the way down from Oregon, and unbeknownst to me, it hadn't been used for a while. The front brake was walking up. So a guy named Mike Robinson that helped me, and he helped Paul Pantone for a while. He's a real good guy, good mechanic. I never used the front wheel brakes, and he started using those, and they walked up, and he was trying harder and harder to get it to go, and it burnt the interconnector wires right off from it. Burnt one post off. And so I took those batteries, and I thought, oh, they're had it. Well, the batteries I brought today are some of those batteries, and they have tape on them, masking, well, they're duct tape, and there's some that have been kind of hurt, and they have other tape on them, and there's some perfect ones, and they're almost 2 years old. I regenerated and rejuvenated them all, and there's 10 of them. And as the Department of Energy said, they balance within hardly anything of each other. In other words, if you have 10 batteries and you put one dead one in here, it'll balance them out perfectly. No other charger will do that. If you have high energy drain, they'll do that. And then the beautiful thing is the energy coming back in is very nominal. Now, where I live in my house, I haven't paid a power bill in 15 years. I have a deep well pump. I have an automatic washer. I have a computer. I have a satellite dish. I have a 27-inch colored TV, stereo, you know, and I do have a gas cook stove, but this is only 110. This very inverter I'm going to show you, and the very batteries will run that. And the other day I was messing around with it, and I didn't want to do anything with this inverter. I tried once to get it to power itself, but it won't do that. And I understand why now, and I was afraid I ruined it, but, you know, so it'd be like perpetual. But I had less than 15 watts going into it. It was putting out 160 watts right out the gauges. And what I'll show you, you know, and I wished I could have had it right here, wished I could have drug it down here. But quite truthfully, there's no way that's physically possible. And the only way we could do that is, you know, have a complete separate and move everything and take a half a day and relocate it. But it will be there, and we'll take a break here, and people are willing to come and see it. As long as, you know, we don't mob each other, that's what I didn't want. Now, I don't know how much time have I got left? I'd like to take a few questions.
Yeah, got about half an hour.
Oh, I still got a half an hour. Good, I'm still going strong here then. Okay, and I want to go on one more with you then. It's where I live at my house, going to that. And it was published also by Steve Ellsworth a long time ago. And it heats itself, it cools itself. It has a big walk-in refrigerator. People come from all over the world. You know why they come and see me? It's kind of like Evel Knievel. I said, you know, if you don't make that jump, people are going to demand their money back. And he said, hey, you stupid fool. He said, that's why they come to see me crash. I guess that's what made me arrogant and belligerent, because more people wanted me to crash and wanted me to not make it, wanted my inventions to be crummy or disprovable, and they're not. So they come from all over, and they stay at my home, and they cannot believe it. And when they leave, one of the things they like to do is go down in the cosmic cooler. And so recently, I found out years ago that you could take cell tissues, meaning apples, oranges, tomatoes, cucumbers, and put in there, and then you could eat them. And they would get younger. It would make you get younger. And so recently, yeah, here's a picture of it, and here's an article about it. Now, this is written by Ralph Sudas, and that was funny. I sent him this article.
You can run right to noon, so you got
Okay.
about 23 minutes.
Okay, and I sent him this article, and somehow he became the inventor and took the credit of it. And here's his picture on here, and he deleted me from it and started selling the plans. Okay? And this is the kind of, you know, this is the kind of things that upset me just a little bit. And this is right here. Okay? Steve Ellsworth records these sessions. He sells a lot of videos. You know, I get nothing. I've attended all these lectures, you know, on my own money. I went to Washington, D.C. in '94, got the nuclear reactor shut down, spearheaded that effort with the Russian scientist, the Native American. I got nothing for it, but whether people like it or not, and that was kind of made a lot of anger towards me because I live right by the nuke site, and all those people lost their jobs. Why do you think I did that? Today, they've caught up with me and found out that atomic radiation is the worst problem we got, and it isn't the sun that's killing us of cancers. If there's so much background radiation, you can get a Geiger counter and go outside right here in Salt Lake City, and the rating is worse than if you smoke 3 packs of cigarettes a day. And before 1945, it's documented by the federal government, there was no nuclear background radiation. And do you know why they put you in when they do CAT scan, they put you in a big tube? It is not to protect you. It is because the background radiation will mess up the test. And you can look in this book, if you disbelieve me, and you can read this book about all the reactors made in the first CAT scan they developed out there. They had found a big old piece of big pipe, steel pipe, I believe it was, and they built a machine inside of there to keep out the background radiation. And not only that, they used to build injection wells. This is what really got to me. They called them injection wells. Doug Cushman and some of those guys from Blackfoot and around would drill these wells, and it tells you their thinking. It was so primitive in what they thought that they would have this chem plant, and they would dump this water right down these holes, and this is a drinking water that flows out of the Rocky Mountains down into your aquifer and everybody else. No wonder we got cancer. So I took it upon myself because I could see that. Well, now I'm taking it on myself to appeal to some of you people that we got to change our ways. I believe that this is a way we can do it. I think it's feasible. These units are for sale today, right today, just like the accurate injection was. The inverter, you can buy right off the shelf. Costs $650 with the remote control. It's really a good one. The factory is backing us and you on this. You can get the batteries right out of Walmart. They cost you $125, and they're really some good ones and have tremendous low end torque. The only thing you get from me is a battery charger. You can even get these. They're $150, but you've got to put either a variable in here or a transformer. The transformers we're using now, they just went up almost $70 in the last 3 months. Everything just keeps going up. But anyway, you can plug this in the wall, cut your power bills. You can have it for your shop and practically eliminate your power bills. You can hook up your RV by taking 2 batteries and putting 24 and go off and have a good time. If you get around to plugging it in, oh, so be it. If you don't plug it in, so be it. It'll last a long, long time. And we have one guy, and this is a kind of a sad story. He's an older guy, and he fell down and broke his hip. And so he got help from his family and that, but you know, they wanted to put him in the rest home. And he's a medical doctor, and they wanted to put him in the rest home. He said, "Oh no, not that." And I said, "Well, what, you're a doctor?" He said, "Oh no, all doctors know if they get you in the rest home," and I'm gonna call it what it is, they give you drugs. And you know, when you get these drugs, once they get them into you, he said, "You never get out of that place. I don't want to go there. Would you help me out, Sonny?" So he came to my house. So meanwhile, they shut off his power bill because he's laid up in the hospital, paying a big fat bill to the hospital, see? So now he's got no power. He's had to spend a lot of his money, and he's recovering from a hip. So I said, "Well, why don't we, I really need some tests. Let's take these to your home and see what they'll do." So I took him 2 of those batteries that I had charged. It was unbelievable. He could run his radio, he could run his reading light, he could run a few lights off there. And he called me up just before I came down here. I said, "How you holding up?" "Oh," he said, "it's still working good." I said, "That's unbelievable." So this type of energy apparently does something that no one ever dreamed of. And I got this electric scooter. You've probably seen me riding around on it. And the reason I've been doing that is because I've been discharging the batteries. Now, when we go out there and charge those batteries, remember the gauges don't lie. And people are going to say all kinds of things, but the gauges never lie. When they take your heart and blood pressure, the gauges tell them where to go. When we put an analog meter, ammeter on a circuit, the gauges tell us what is going on. So you can put these gauges on, and what will happen is it'll show 0.00 energy draw. I had this recently up in Livingston, Montana for Electric Show. We had a stereo boombox on there with a CD disc in there, plus the scooter. Still it showed no energy being taken out of it, 0. And back in the back of it, I think we was putting in less than 15 watts. Okay, has anybody got any questions? Seems like everybody's falling asleep. It must be getting boring. Anybody got any questions?
If anybody has questions, they could come to the mic, actually.
Yeah, has anybody got some questions? Let's get this interesting, you know, because I'm sure that somebody must have some questions. I mean, there's nobody out there that wants to diminish your power bill or have it completely eliminated, right? Nobody. Go ahead.
I got lots of questions.
Go ahead.
You're saying this device right here that's on the table.
Don't call it a device. It's an apparatus.
Okay.
Okay. Tesla would roll over in his grave if he heard that. Okay, go ahead.
This apparatus that you have right here, you're saying that thing will put out 12 kilowatts?
This particular one will put out 1,500 horsepower. That's 1,500 horsepower, and it's a kilowatt, so it'd be 1,500 kilowatts. This particular machine, yeah. This was the
The
first
one that's plugged in now, how much does that put out?
These here are 2 kW.
2 kilowatts.
Yep.
Okay. And do you have that demonstrated out on your booth?
I have it all demonstrated. I have another one just like this that we will be showing. It charges 10 batteries, and we were showing that we would be pulling out about more than 5 kW out of it.
Are you using it primarily to charge batteries, or can you do direct power such as?
Well, you can use direct power, and efficiency is still good. Like this here, you can plug it in, and you can hook that electric drill to it. It pulls 10 amps. It'll put out about 15 continuously, and you can hook, something else to it'll pull about 1,500 watts.
How long have you had that device? How long have you had the apparatus?
How long, this particular one?
Yeah.
Probably about, how long have I been here? About since I got it. I brought it with me. It's brand new. It's just put together. But the other one that's out there that is being demonstrated, I've had it for probably 2.5 years. This here particular one 5 years ago.
And you said that you're selling those?
Yeah, they're for sale. These are $150 complete. And you can either, and this is my thinking, this only puts out 125 volts. So you have to have at least 10 batteries. Now you can either put a variable, well, it's like a rheostat in front of this and change the voltage, or you can put a transformer. You can buy transformers as small as for $30, but they might only put out a little bit. What we have is one that puts out a whole lot, and it costs us, well, they're almost, they're about 275 or 80 bucks now. They used to be like,
How many of those have you sold?
These here, I sold 10 of them. And people would tear them down. In fact, I got them back in Tennessee. And then you can plug in on 220, not this particular one, but you can plug the other one in 220 and it will charge 4 batteries instead of 2. And that way you can have 20 kW come out of it. But you see, it's elusive because as Tesla said, if you discover his work and study it, you see the input and output are not the same as. In other words, you put a little bit in, it's called a modulator, or like a half-tune wave or half-tune diode or anything like that. It's a modulator, and what it does is keeps moving around. But that has nothing to do with the other part of the coil, just like a transformer, so you take a lot out. We'll give you an example. There's 38,000 out there on the line, okay? But there's no amps. So you run it to a transformer, you get 240 volts, use it single phase, and it'll come in about 223, and that's what we got out here, 223 volts, you see, and you don't have no amps, so that's a problem. So if you put in this capacitor and you got 1,000 amps, absolutely, when your washing machine kicks on and calls for 30 or 35 amps or 20 amps, it's not going to come off the power line. Thereby your meters, induction meter, is not going to move. It's going to stand in its tracks.
The basic technology of that apparatus, is that the John Bedini technology?
John Bedini, Tesla, Edison. He was the first one to have what they called the Edison effect, or the cold tubes, or the brush effect.
Looks like we have more people asking questions. I'll let
Okay.
them. Thank
Okay.
you.
Go
I'll
ahead.
talk to you later.
Yes, sir. I'm under the impression that apparatus is developed and built with modern industry parts. Is there a mathematical or chemical or physical basis?
Yeah,
The-
Cherenkov.
Okay.
Cherenkov, the work of Cherenkov, John C. Bedini, Nikola Tesla,
Okay.
Albert Einstein, it's called EMC squared,
Right.
Pons and Fleischmann, Dr. Sonny Ward, who else? It goes on and on. Everybody has always predicted, and this uses off-the-shelf parts. You can buy them. The whole big system's $1,500 complete everything. And it's backed by factory warranties on everything. The batteries are backed by Walmart for 3 years. I think the inverter's backed for a year or whatever, and they've been really, really, really nice with this, and this, I guess, is backed by me. If it burns up, I'll give you another one. What?
Okay. I guess my last question is, when those other gentlemen were working on the theories, a lot of these industry parts weren't around then. Has there been a modern interpretation of the mathematics with that specific design that appears to work?
Yeah, EMC squared. When the energy, when electrons move faster than the speed of light, according to Cherenkov, and that's pretty modern. Come out of Berkeley, that it creates antiprotons or anti-neutrons or antimatter, or Bruce published it in his book as 0-point energy, and that's what we'll show you. Pons and Fleischmann, and I want to relate on that. You know why they were able to accomplish that at that time? Because the atmospheric conditions were just perfect. And when the atmospheric conditions are perfect, people will always say, oh man, you know, it's breaking. You know, it's me a minute ago because I broke my leg, you know, but you just feel that and you get awake in pain. You know why that is? Because the ions in the air are all negative. All ions are in the air are negative, and they form on these clouds, and when they're just right, it makes it so you're possible to transfer those. Now, my house, I didn't tell you about this, is one huge capacitor. It has 20,000 square feet of silver mylar off the ground. And so when these storms come in fact, it attracts a lot of electrons, and it makes this change. Human beings are able to take it, and they actually change too, they get younger.
Right. All right. Thank you very much.
You bet. Somebody else?
Yes, my name is Harvey Fiala. I'm an electrical engineer, and I would like to talk about your little device there for a moment.
Apparatus.
The little charger?
Apparatus, yeah.
Apparatus.
Charger, yeah.
Okay. What is its ratings again?
This one is 2 kW.
Pardon?
2 kilowatt hours, 2 kW. It'll put out 2 kW continuous.
2 kilowatt
Yeah.
output.
Well, actually, it'll go a little more than that, but it's used for
Yes.
2 kW.
And have you ever put a resistive load on it?
Oh, hell yeah.
And at
They
the
did
time
that
that
in
it's-
NASA. You want to hear that little story?
No.
So the guy come out and he had a 5,000 ohm resistor on it, and he discovered just in a few minutes it set it afire, and he went to get it out because he underestimated the power. This thing only weighs 2 pounds, and it's 4x4 by about 2 inches. And so then he got a big, heavier one, and I don't know what it went to, but it was even more, and it looked like a blue crayon. He hooked that up, and it fried it in just a microsecond. And the reason he done it, if you're not pulling a load out of it on resistance, it won't activate.
When it puts out 2,000 watts, how much power does it take in?
Less than it puts out.
Less than how much?
Less than it puts out.
About how much?
I don't know, different, it depends on, let me put it this way. If you drink a glass of water, or you drink 2 glasses, your stomach's only so full.
Well,
Okay, but wait a minute. So it depends on the impedance of the load. Do you understand that?
impedance of the what?
Load, L-O-A-D, the
Right.
impedance of the load.
Absolutely.
So the more the impedance, the more it'll draw. If there's no impedance, it'll draw none. Because why is the electrons don't go anywhere? We'll give you an example. Electric motor, it'll just go around the motor, and go around the motor and come right back into the battery and go through the battery and around the motor. And consequently, I can prove that because the motors don't get hot and they don't spark an arc.
You don't need to prove it to me.
Okay.
You say the man had a 5,000 ohm resistor?
Yep. The first one.
The first one.
It burned it up in a few seconds.
Okay. And that puts out how many volts? That little
100, it starts out at 100. It starts out at 67 volts.
57 volts.
67.
67.
Okay, when you load it, that's what it said. It depends on the impedance, or the Tesla called it impedance. That's what I call it.
But if
okay, now wait a minute. Let me finish. Don't go on like a racehorse. I haven't even answered the question. So then, if you load it, it puts out 124 volts. Okay, then if you keep loading, it goes up. In this particular one, because that's how it's programmed, okay, it goes up to 144 volts, and I'll show you out there. Then it drops back, and the one we took up to Seattle that we had programmed different, that I already gave a show, and Bruce Perot show, he's got the tapes for it, it went up to 167 volts, but the batteries never even got warm.
Okay. May I speak for a moment
Now you go
without
ahead.
being
Now you-
interrupted?
Sure.
Okay. If you have a 5,000 ohm resistor on there, and just suppose it was putting out 100 volts as a nice round number. The equation for power is V squared over R, and if you take 100 and square it, that's 10,000. Now, if you divide that by the resistance, which is 5,000, you get 2 watts. 2 watts. And, and that would never burn up a 5,000 ohm resistor unless it was a quarter-watt resistor.
Okay, well, the reason we was trying to load it so the oscilloscope wouldn't work.
But you see,
I didn't do it.
There was only 2 watts being put into that 5,000 ohm resistor.
Well, what's that got to do with anything?
Pardon?
What's that got to do with anything?
I'm showing that it cannot put out that much power. If it's putting out 100 volts into a resistive load, 100 squared over 5,000 is only 2 watts.
Well, what's that got to do with anything? The only
You're
reason.
saying it puts out, what'd you say?
A kilowatt
50
and a half, 2 kilowatts.
1.5 kilowatts, okay? And that's 2 watts is 1,000 times less than
I know that.
1.5 kilowatts.
I'm agreeing with you.
Okay.
With you.
Are you familiar with the term power factor?
Oh, yeah. Believe me,
Okay.
I'm familiar with it.
Okay, you
Now,
need to
can I
apply-
say something?
Yes,
Before
you
you
may.
railroad me right over? The reason we done that at NASA Lab, all we was trying to do is load it enough to get the oscilloscope to show the wave. Out here, I'll show you it powering a big electric drill that has 10 kW. I'll show you powering a chop saw, that whatever, and it puts out the load. And if you see the load, it'll blow the fuse because that's what it's
I
used
looked
at.
at all your devices out
Okay.
there, and all of them have a power factor which is not unity. They're all inductive devices. And so you cannot run that kind of a test. You need to have a load bank of resistors to try to demonstrate how much power
Well,
it can
listen,
handle.
If you put a load resistor on there, what's that got to do with anything? You
It has a power factor of
Wait a
1.
minute, wait a minute. A load resistor doesn't interest me at all. You know what interests me? Is how much power I can get that I can use, like for my television, or for my deep well pump, or for my washing machine. I could give nothing about that other stuff because what does it matter?
I'll tell you what should interest you is how to measure power output accurately. Thank
Okay.
you.
You bet. I've heard this before. Have you got a question? We got 3 minutes left. Go ahead. Anybody else?
Looks like we got one more there.
Sonny, you said that the diode in the box was you had changed it in some way or programmed it to do certain things.
Yeah.
Can you explain? I mean, is that the component that kind of transfers the quality of the energy from normal electricity to the form that you give to the batteries? Can you describe to us a little bit about how you see that quality change happen?
Well, how I think it happens is this. Okay, we'll say you got a piece of tinfoil. Okay, you can etch certain lines on there and use it. Let me give you an example. In the old days, in the Edison times, they used to use that for the transmitter, you might say, in the old phonographs. I have one. So when you put the right energy or level of energy into that, you can have it where it takes on electrons, and program it to retain those electrons. So it means it'll let so many through or not so many through.
So
It,
in other words,
it actually imprints it, and see these here where you would call like a footprint, I'll call it. That's what they call them in transistors, is the same thing. Or nowadays we got computer chips, but these will do the same things, but you got to have the right program and the right way of doing it. You get a laptop computer, you hook them up, and these here will put out a lot more than these here. And the one out there will put out more than this in here, but they're identical except the way it's been. It's called PLC, Programmable Logic Control. A lot of things can be done that today with the technology. The computer, that I think we're about done here, but the computer that runs the Implosion machine now, that's what it has, and it's fantastic.
Thank you.
Yeah, you bet.
Well,
Test. Well, that draws to close our morning session. I want to thank Sonne for a very fine presentation. I'd also like to draw your attention.